Guys, sorry for the confusion. First of all, hope the Keystone exam went well. Um, and you just have one more day, and then we will be able to talk about all of this information in person. But I just wanted to give you a video so you could watch it, just so you could kind of stay on top of what we're covering in class. So before or yesterday, I would say, what we were talking about was adding and subtracting rational expressions. So we talked about kind of the basics. We talked about how to add and subtract rational expressions with a common denominator, and then we talked about how to find the LCM. Today, what we're going to do is we're going to take kind of both of those situations and combine them together. So first of all, I'm going to review the step process that we talked about yesterday as well of how to add and subtract. So the first thing that we have to do is we have to find the least common denominator. In order to find that, we need to factor the denominators and take the highest power of each factor or factored expression. Remember, it doesn't matter whether the factor is included or not, we still use it. The second step, we are going to make each fraction equivalent to the LCD. So we're pretty much like multiplying by what the missing piece is. So if it has one part of the LCD but missing the other, we multiply by what it's missing. After we make them equivalent to the LCD, we are going to simplify our numerator. So this could mean distribution, it could mean FOILing, combining like terms. We're looking to put the numerator in its simplest form. Once you simplify the numerator, then you are going to simplify the fraction as a whole by factoring the numerator. So yesterday we talked about this first example, so I'm just going to bypass that and go to the next example. So we have x over x plus 2 plus negative 8 over x squared minus 4. Like we said, step one is we need to find the LCD. In order to find the LCD, we need to factor the denominator. So the first denominator, x plus 2, isn't going to factor, but what I like to do is just write in the set of parentheses. Our second denominator of x squared minus 4 is going to factor to x plus 2 times the quantity of x minus 2. Now, when you go to find the LCD, remember you are taking each and every factor regardless of whether it's shared or not. So the first factor I see is x plus 2. So we're going to use x plus 2. The second factor I see is x minus 2. Now again, it's comparing, not combining. So our LCD is going to be x plus 2, x minus 2. From here, step 2 is we're looking to make each fraction equivalent to the LCD. So if we look at our first fraction here of x plus, or x over x plus 2, it has a denominator of x plus 2, which is the same as the LCD. It's missing the x minus 2. So we're going to take technically the numerator and the denominator multiplied by x minus 2. It's most important to represent in the numerator. Now, if we look at our second fraction, it has an x plus 2. Well, so does the LCD. X minus 2, x minus 2. Already equivalent to the common denominator. So what I'm going to do right now is just rewrite what we have in our numerator. So we have x times the quantity of x minus 2 minus 8, which are all the terms in our numerator, now over our common denominator, x plus 2, x minus 2. From here, we are now going to simplify the numerator. With that, what we need to do is we need to distribute. So when we distribute, that's going to give us x squared minus 2x minus 8 over x plus 2, x minus 2. From here, the final step is we are looking to simplify the entire fraction. In order to simplify the entire fraction, we're looking to factor the numerator. So our numerator in this example is actually going to factor x minus 4 times the quantity of x plus 2. Once something's factored, we kind of cross it off. We have an x plus 2 in our numerator, canceling with the x plus 2 in our denominator, leaving us with an x minus 4 in our numerator over an x minus 2 in our denominator. And that would be our final answer there. So that's one example in which we are adding. So example 6, we didn't do example 6 in class. That one's a little bit more, not challenging, I would say, but it doesn't align with what you're going to be assessed on. So we got to bypass that one. And we looked at the next example. So in this example, x over x plus 3 plus 2x plus 6 over x squared plus 6x plus 9. Again, we're following the step process. Step 1, find the LCD. We find the LCD by factoring. So our second denominator is going to factor to x plus 3 times the quantity of x plus 3. Well, if we look, it's the same expression multiplied by itself twice. So we're going to rewrite that as a power x plus 3 squared. So when you go to find the LCD, remember, you're using every factor, but the highest power of every factor. So if we have x plus 3 technically to the first compared to x plus 3 squared, we're going to use the x plus 3 squared. Step 2, we're looking to make each fraction equivalent to that LCD. First fraction only has one x plus 3, so we need to multiply it by another x plus 3. The second fraction already has the x plus 3 squared, so we can kind of leave it as is. So again, if we rewrite what's now in our numerator, we have x times the quantity of x plus 3 plus 2x plus 6 over our common denominator of x plus 3. Just like before, from here we're simplifying our numerator. The way we're going to simplify is start by distributing. We're going to end up with x squared plus 3x plus 2x plus 6 over x plus 3 squared. We are combining like terms in our numerator. That's going to give us x squared plus 5x plus 6 over our common denominator. Now remember, you can pause this video at any time if I'm going a little bit too fast, you need some time to copy down. So at this point, we have our simplified numerator. What I'm going to do now is factor our numerator. That's going to factor to x plus 3 times the quantity of x plus 2. Now we have 1x plus 3 in our numerator. That's going to cancel technically with 1x plus 3 in our denominator. So instead of having an exponent of 2 now, it's only 1. So really, we're left with then x plus 2 over x plus 3.